I conducted an experiment where one car rolled down a ramp and collided with a stationary car, in which the stationary car was placed at different distances from the ramp. My goal was to find the final velocities of the cars in the 6-inch collision, as shown here. After the collision, car 1, or the black car, moved negative 0.5 inches in the x direction and 4 inches in the y direction. Car's 2 coordinates are shown. Shown are rough sketches of the initial and final collision. But how do we solve this equation? It's a two-dimensional system of equations in which we need to find the velocities in the x and y direction to find the final velocities. We know mass 1, mass 2, velocity 1 initial, and velocity 2 initial, including their velocities in the x and y direction. To find the velocity 1 initial, we use the distance over time formula, which equaled 0.66 meters per second. To solve for the velocities in the y direction, we need to use the conservation of momentum formula. And it's important to remember that velocity 2 initial equals 0. This is because car 2 is at rest to begin. First, we need to set up the equation to solve for velocity 1 final in the y direction. We then substitute that equation into the kinetic energy equation to solve for velocity 2 final in the y direction. Then you need to simplify and manipulate the equation to solve for velocity 2 final in the y direction. Once you do that, you can plug the values in and simplify to solve for velocity 2 final in the y direction. Now we can plug that value into the conservation momentum equation to solve for velocity 1 final in the y direction. Once you plug your values in, you just have to simplify the equation to solve for velocity 1 final in the y direction. But does this make sense? The velocity 1 final in the y direction is 0.09 meters per second. This makes sense because the black car would lose some momentum after the collision. Velocity 2 final in the y direction equals 0.48 meters per second. This makes sense because the second car would gain some velocity after the collision. The conclusion is that they make sense. Now it's time to solve for the velocities in the x direction. We're going to do the exact same things we did for the y direction, except for the x direction this time, to find our velocities in the x direction. But do these values make sense? Velocity 1 final in the x direction equals negative 0.0965 meters per second, which makes sense because the car moved in the negative x direction after the collision. Velocity 2 final in the x direction equals 0.0819 meters per second, which makes sense because the car went up in the x direction after the collision. They make sense. Now that we have our final velocities in the x and y direction, we can solve for the final velocities. We can make a right triangle with these velocities, which allows us to use the Pythagorean theorem to find the final velocity. It's the same deal for car 2. All we need to do is plug in our x and y velocities into the Pythagorean theorem equation to find our final velocity for mass 1. We do the same thing to find the velocity of mass 2. This makes sense because mass 1 lost some velocity after the collision. On the other hand, mass 2 gained velocity after the collision. This is demonstrated in the collision shown here.